Imagine looking through the eyes of cosmic giants that can peer 13 billion years into the past, detect planets trillions of miles away, and unveil secrets of the universe our ancestors never even dreamed of discovering. What if I told you that right now, as you're watching this video, incredible machines are floating in space, capturing light that has traveled longer than Earth has existed? Today, we're going to meet the true superheroes of modern astronomy, the space telescopes that have revolutionized our understanding of the cosmos. Hello, cosmic explorers. Welcome to Cosmic Frontiers. Today, we're embarking on a fascinating journey through the golden age of space telescopes. We'll discover how Hubble showed us the universe's infancy, how James Webb is rewriting astronomy textbooks, and how the upcoming Roman and Euclid promise to unravel the greatest cosmic mysteries. Get ready for a trip that spans from the most colorful nebulae to the most distant galaxies ever photographed. And remember, we're on an incredible journey towards our first 1,000 cosmic explorers, and each one of you is essential to this adventure. Before we dive into space telescopes, we need to understand why they became necessary. Imagine you're trying to observe stars through a moving swimming pool. The water distorts everything you see, right? Our atmosphere works exactly like that for ground-based telescopes. The air is constantly moving, creating turbulence that makes stars twinkle and blurs images. It's like trying to read a book through a curtain of water. That's why putting telescopes in space was a revolution, equivalent to stepping out of the water and seeing the world with crystal clear clarity for the very first time. The first major protagonist in our story is the Hubble Space Telescope. Launched in 1990, did you know that Hubble has already completed over 34 years observing the cosmos? To put that into perspective, when Hubble was launched, the internet as we know it didn't even exist yet. This tireless veteran orbits our planet at an altitude of 547 kilometers, traveling at 27,000 kilometers per hour. That's like completing a full orbit around Earth every 95 minutes. Hubble revolutionized our view of the universe in ways that still leave us awestruck. Before it, we didn't know the exact age of the universe. Hubble observed variable stars called Cepheids in distant galaxies, allowing us to calculate that the cosmos is approximately 13.8 billion years old. Imagine discovering the age of something as grand as the universe itself. It was like finally figuring out when our cosmic home was built. One of Hubble's most impressive discoveries was the accelerated expansion of the universe. Scientists Saul Perlmutter, Brian Schmidt, and Adam Rees used Hubble data to study distant supernova and uncovered something completely unexpected. The universe is not only expanding, but this expansion is accelerating. This led them to postulate the existence of dark energy, a mysterious force that accounts for 68% of everything that exists. It's like discovering your house is growing on its own. And not just growing, but growing faster and faster. Hubble also gifted us with images that defined a generation. Who hasn't seen the famous image of the pillars of creation in the Eagle Nebula? These colossal structures of gas and dust, where new stars are being born, stretch for light years to grasp the scale. Imagine towers that take light for years to travel from one end to the other. Hubble showed us stellar nurseries, star cemeteries, colliding galaxies, and even planets orbiting other stars. But here's something that will surprise you. Hubble was almost a complete disaster. When it was launched, scientists discovered that its main mirror had a microscopic flaw, a spherical aberration of just 2.2 micrometers. That might seem tiny, but in the world of precision astronomy, it was like having glasses with the wrong prescription. Fortunately, in 1993, astronauts installed a corrective system during one of the riskiest service missions in space history. It was like performing cataract surgery on a cosmic scale. Now, let's jump to the present and near future with the James Webb Space Telescope, which began its scientific operations in 2022. If Hubble is our reliable veteran, then Webb is our young prodigy with superpowers. While Hubble primarily observes visible and ultraviolet light, Webb was designed to capture infrared light. Why is this revolutionary? Imagine you have two types of glasses. One that sees normal colors, and another that sees in the dark. Webb is the pair of glasses that sees in the cosmic dark. Infrared light allows Webb to see through the cosmic dust clouds that block Hubble's view. It's like having X-ray vision that penetrates walls. More importantly, due to the expansion of the universe, the light from the most distant and ancient galaxies has been stretched into the infrared. This means Webb can literally see further into the past than any previous telescope. We're talking about observing galaxies when the universe was only 400 million years old. That's like seeing baby pictures of the cosmos itself. Webb's mirror is another engineering marvel. With a diameter of 6.5 meters, it has almost 3 times the light collecting area of Hubble. To put that into perspective, imagine the difference between a small window and an entire glass wall. The amount of light that enters is drastically greater. But here's the ingenious trick. This giant mirror needed to fit inside a rocket, so it was designed to unfold like cosmic origami once in space. Webb is also positioned completely differently from Hubble. While Hubble orbits Earth, Webb is at the L2 Lagrange point, 1.5 million kilometers from Earth. This is a gravitational balance point where Webb can remain aligned with Earth. While both orbit the Sun, it's like being on a perfectly balanced cosmic seesaw. This position allows Webb to maintain an extremely low temperature, essential for detecting the faint heat from distant cosmic objects. Webb's first discoveries are already rewriting astronomy textbooks. It detected galaxies so ancient and massive that they challenge our models of what the early universe should have been like. It found water in exoplanet atmospheres, revealed the chemical composition of planetary nebulae with unprecedented detail, and even observed stars forming in real time. It's like having a microscope that works in reverse. The further it looks, the more details it reveals. One of Webb's most impressive images is of the deep field compared to Hubble's famous deep field. Where Hubble needed days of exposure to reveal distant galaxies, Webb achieves the same result in just a few hours, but with much more detail. It's the difference between using a flashlight and using a spotlight to illuminate a night scene. Let's now meet the next members of this extraordinary family of cosmic explorers. The Nancy Grace Roman Space Telescope, named in honor of the mother of Hubble, is scheduled for launch in the middle of this decade. If Webb is our infrared specialist for distant objects, Roman will be our cosmic investigator to unravel the mysteries of dark energy and dark matter. Roman will have a field of view 100 times larger than Hubble. To understand this difference, imagine the difference between looking through a straw and looking through a panoramic window. This wide view will allow Roman to map the distribution of galaxies on gigantic scales and observe how dark energy affects the structure of the universe throughout cosmic time. One of Roman's most exciting missions will be the hunt for exoplanets using gravitational microlensing. When a planet passes in front of a distant star, its gravity acts like a cosmic lens, momentarily amplifying the light from the background star. It's like using gravity itself as a telescope. Roman will be able to detect rocky planets similar to Earth, including those orbiting far from their stars, where traditional methods cannot find them. Roman will also conduct unprecedented research on supernova to better understand dark energy. It will observe thousands of these stellar explosions throughout its mission, creating a three-dimensional map of the universe's expansion with never-before-achieved precision. It will be like creating a 4D movie showing how the cosmos evolved over the last billions of years. Last, but certainly not least, we have the Euclid Space Telescope, a mission from the European Space Agency that began its operations in 2023. Euclid has a specific and fascinating mission: to map the geometry of the dark universe. While we only see 5% of the universe in the form of normal matter, the other 95% is composed of mysterious dark matter and dark energy. Euclid is our cosmic detective dedicated to unraveling these mysteries. Euclid will observe billions of galaxies to measure how their shapes have been distorted by weak gravitational lensing, a subtle effect where dark matter bends space-time and slightly distorts the images of distant galaxies. It's like detecting invisible footprints in the cosmic sand. Imagine trying to find something completely invisible just by the effects it causes on what's around it. That's exactly what Euclid is doing. This telescope will create the most detailed three-dimensional map of the universe ever produced, showing how dark matter is distributed on colossal scales. It will be like having an X-ray map of the cosmos' invisible skeleton. Euclid will observe galaxies up to 10 billion light-years away, allowing us to see how cosmic structures evolved over 3/4 of the universe's history. Something fascinating about Euclid is its ability to measure the redshift of galaxies with extraordinary precision. Redshift is the stretching of light due to the expansion of the universe. The more distant a galaxy, the more its light is shifted towards the red end of the spectrum. It's like the Doppler effect we hear when an ambulance passes us. but applied to the light from galaxies. Euclid will use this information to build a movie of cosmic evolution with impressive temporal resolution. Now, let's imagine what these four cosmic giants together mean for the future of astronomy. It's like having a symphony orchestra where each instrument contributes its unique voice to create a complete cosmic symphony. Hubble remains our lead violinist, providing detailed images in visible light. Webb is our infrared maestro, revealing the deepest and most ancient secrets. Roman will be our percussionist, mapping the rhythm of cosmic expansion. And Euclid is our harmony expert, revealing how the entire invisible structure of the universe connects. Together, these telescopes are answering some of humanity's deepest questions. What is the universe made of? How did the first stars and galaxies form? Are there other planets like Earth? What is the dark energy that dominates the cosmos? What will be the ultimate fate of the universe? These aren't just scientific questions. They are philosophical inquiries about our own existence and place in the cosmos. Future discoveries promise to be even more revolutionary. Webb might find the first stars that formed in the universe, made only of primordial hydrogen and helium. Roman could discover rogue planets, worlds, that were ejected from their solar systems and now wander alone through the galaxy. Euclid might once and for all resolve the nature of dark energy, perhaps by discovering that our understanding of gravity needs to be revised on cosmic scales. Imagine the images yet to come. Photographs of rocky exoplanets with detectable atmospheres, detailed maps of how dark matter is distributed around galaxies, cosmic time lapses showing how the universe evolved over billions of years. Each new discovery not only answers old questions, but also reveals new mysteries we didn't even know existed. There's also something profoundly human in this story. Each of these telescopes represents decades of work by thousands of scientists, engineers, and technicians around the world. They are monuments to human curiosity and our capacity for international cooperation. When we see an image from Webb or Hubble, we're seeing not just light from distant stars, but also the brilliance of human ingenuity. The era of space telescopes has also democratized astronomy in a unique way. All images and data from these telescopes are made publicly available, allowing students, amateur astronomers, and even artificial intelligences to make discoveries. It's possible that the next great cosmic discovery will be made by someone analyzing public data at home, using just a computer and curiosity. Recapping our cosmic journey today, we saw how Hubble revealed the age and expansion of the universe to us, transforming our understanding of the cosmos. The James Webb is rewriting the history of the first galaxies and showing us distant worlds with never before imagined detail. Roman promises to unravel the mysteries of dark energy and discover thousands of new worlds. And Euclid is mapping the invisible skeleton of the universe, revealing how dark matter shapes everything we see. But perhaps the most extraordinary aspect of this golden age of space telescopes is how it connects us with our own cosmic essence. Every atom in our bodies, except hydrogen, was forged in the hearts of stars that lived and died long before the sun existed. When we look at the images from these telescopes, we are literally seeing our cosmic ancestors, the stars that created the elements that make us up. We are not just observers of the universe, we are the universe knowing itself. Cosmic explorers, which discovery from these space telescopes impresses you the most? Was it learning that the universe is expanding faster and faster? Seeing the first galaxies that formed when the cosmos was just a baby, or perhaps the promise of finding Earth-like planets? Let us know in the comments which aspect of this astronomical revolution sparks your curiosity the most. And since we're talking about future discoveries, what mystery of the universe do you want me to talk about in the next video? Supermassive black holes, the search for extraterrestrial life, the ultimate fate of the cosmos? Leave your suggestions in the comments. After all, you are an essential part of this journey of discovery. We're on an incredible journey towards 1,000 cosmic explorers. If this video expanded your horizons and sparked your curiosity about the mysteries of the universe, join our crew by clicking subscribe. Like this video if it made you feel part of this extraordinary cosmic adventure, and share it with someone who also loves discovering the secrets of the cosmos. In the next video, we'll dive even deeper into the universe and explore another fascinating mystery that these telescopes are helping to unravel. Until then, keep looking up and dreaming of the infinite possibilities the cosmos holds for us. Remember, we are all made of stardust, and every new discovery brings us closer to understanding our true cosmic origin.